This is problem 15.1.7, and it says that there is a statistics professor who would like to develop a regression model to predict the final exam scores for students based on a few different independent variables. So we have GPAs, which is our x sub 1, the number of hours that they studied for the exam, which is x sub 2, and the number of times that they were absent during the semester, x sub 3. So we have some data in the data table here, and I've just got a brief look at the question, and then split the screen into an Excel spreadsheet where I have the data posted. And just jumping ahead a little bit, I have the prediction variables that we are going to use for a specific scenario later on in the problem. So I'll show you first of all how we can just run the regression quickly in the data analysis toolpack. So we've got our y variable here, which is a score. It's our dependent variable. And then we have our three independent variables, GPA, hours, and absences. And we are using a 95% confidence level, so alpha of 0.05. And the output range, try to get in the view here. Okay, so this is our output for the data analysis toolpack. And from this, we could calculate the specific prediction that we're given later on in the problem of examining a scenario where we have students with a GPA of 2.95, and they have studied for 5.5 hours for the exam, and they have been absent 3 times during the semester. So we could make a prediction of an exam score based off of this scenario just by utilizing the regression equation. And we would solve that by taking the intercept coefficient and adding our independent variable coefficients times their respective variables here in the scenario. Hours times 5.5 and absences times 3. Okay. So based off of this given scenario, we would predict that the exam score for a student in this case would be just a little over 83%. Format that a little bit here, so 83.16. Again, we're just using the coefficients that were determined through the regression analysis. And now I want to examine the confidence intervals for, or both, I should say, the confidence interval and the prediction interval for this specific scenario here. So remember that the intervals here, this lower and upper bound here, has to do with the an estimate of the population slope of each of these independent variables. So this is not related to the confidence interval or prediction interval for the specific scenario that we're running in this case. So with that, we'll utilize XLStat. And once again, we just need to plug in our details here, the y variable. Should put in 1 second to flip back to the other sheet there. Exam score. And our independent variables here. Output's going to go to a new sheet. We have variable labels included in our ranges that we've highlighted. We are using a confidence interval of 95%, and we have 3 levels, 3 interactions here, so meaning we have 3 independent variables, so that's correct. And for our prediction, we need to input the range of our scenario, so the 2.95 GPA, 5.5 hours of study time, and 3 absences. And from there, we should be set. So the output is already, just from previous regressions, set to ANOVA input, or output, I should say, and I have no charts selected for this example. So if we run this regression, first we need to just verify which levels we're using. So we have GPA, hours, and absences. I'm not doing any factor analysis on this, so click OK. And as soon as we're down here loading, scroll down, again we have our specific coefficients that we got from the data analysis tool pack. We have those here with XLStats. And we have our regression equation here, which is what we use to calculate the predicted score based off of the scenario that we were given in the problem. And that came back with the same predicted exam score of 83.16. And here is what we're looking for as far as intervals go. So here is the confidence interval. So get at 95%, this is just saying that we're 95% confident that the average score for a student with those variables will be 83.16. And then we have our prediction intervals here for that specific observation. So notice again, mean, average, and specific observation. So this is our prediction interval, which is just stating that we are 95% confident that this specific scenario, so a scenario with the values that we used being the 2.95, 5.5 hours, and 3 missed days of class would result in a student getting an 83.16 on the exam. So that's how we can run the XLStat regression to get the intervals that we need for a given scenario.